And welcome back to AP Statistics with Mr. Walton. Today we want to talk about Chapter 8, Section 2, Estimating a Population Proportion using confidence intervals. So first, let's remind ourselves, what are our conditions? All right? They are S, I, and N. S meaning we need an SRS or random allocation. I, independence, which is our 10% rule, and N, which is normality. Now, specifically to proportions, we need to have a statement saying since n times p hat is greater than or equal to 10, and n times 1 minus p hat is greater than or equal to 10, then our sampling distribution should be approximately normal. Be very careful. I expect for all three of these conditions, use complete sentences. So I expect you to write out what you're doing by using complete sentences. An SRS is given in the situation. Independence, wow, looks like I didn't complete that independence word. Independence is established because it's reasonable to assume that 10 times our sample number exists. Okay? And then normality, we only use n times p hat because we don't know p. We can't use it. All right. So let's look at an example so we can talk about what kinds of sentences need to be used. What are all the steps? How do I go through this whole process? So here we go. Example 1. According to a recent study, not everyone can roll their tongue. A researcher observed a random sample of 300 adults and found that 68 could actually roll their tongue. Construct and interpret, that's key. Construct and interpret a 90% confidence interval for the true proportion of adults who can roll their tongue. Number 1, let's talk about our summary stats. What do we know? First off, I know that n is equal to 300. I know my confidence level is equal to 90%. Because my confidence level is 90%, my critical Z is 1.645. I also know that my X number of successes is 68. Therefore, my p hat value is 68 out of 300, which I could leave it like that, or if you prefer, change it to 0.227. No problems with that whatsoever. What else do we also know? We know that the standard deviation of our p hat values in this case is going to be okay, so I got the standard deviation of 0.227 times what is that? 773. And I can leave it like that. Or if you want to work it out, it doesn't matter one way or the other. So there we have this. Next, what is the population in question? What population are we worried about? We're worried about all people. So we are going to be able to infer about all people. What parameter is the one in which I'm interested? And that is, I'm interested in the proportion of people who can roll their tongue. All right. So far we got, this is a basic setup. What comes next? Conditions. Okay. So I've got to have my conditions. S. Okay. It says According to a recent study, a researcher observed a random, aha! So I would say it is given that a random sample is used. For I, it is reasonable Okay, it is reasonable to believe there, wow, misspelled there, sorry about that. There are more than 3,000 adults, so the sample subjects should be independent. That means that the people involved in this random sample should be independent of each other. And then N, and you need to show calculations for this, everyone. So I've got 68 is greater than or equal to 10. Bam. Yes, it is. And here I've got 232 is greater than or equal to 10. Yes, it is. So therefore, the sampling distribution should be approximately normal. Now, since my conditions have been met, we are going to write a continuation statement. And then I'm going to actually write out what's the confidence interval equal to. It's equal to p hat plus or minus z critical times my standard deviation, or my, and I have it there. And then once I have it written out, I know what to plug in, so now I can use my calculator, or I can calculate by hand and get 0.18691 to 0.26643, and I have calculated it. Now, we're good to go on the calculate part. What's the second half? I ask you to calculate and interpret. So what do I need to do next? I need to write my interpretation with 90% confidence. We estimate the true proportion of people who can roll their tongue to be between 18.7% and 26.6%. And we have finished. That is me working it out right in front of you. Now, as a continuation, what could I also ask you about? Right here, example 2. What if I wanted to estimate the proportion of adults who can roll their tongues? Based on the results from example 1, how large a sample is needed for me to actually have my width be only 4% at most at the 95% confidence level? So, for this one, we need to look at the fact that it's a confidence level of 95%. we have a p-hat value, again, of 68 over 300. But I'm interested in my MOE being at most 0.04. So I've got 0.04 is equal to my Z critical, right, times my p-hat times 1 minus p-hat over n. So I've got 0.04 is equal to, now 95 is 1.96. I've got my beautiful 0.227 times my 0.773. If you don't want to round, that's okay. And I don't know what n is, but I want to solve for it. So then I'm going to go through my algebraic manipulation. I'm going to have 0.04 divided by 1.96 is equal to the square root of 0.227, 0.773 over n. I'm going to have this quantity squared is equal to 0.227, 0.773 over n. I'm going to end up cross multiplying and solving for n, and I'm going to get n as 1685.22, which means n must be greater than or equal to 1686, because we always push up or round up. We do not follow regular rounding rules because I need my width to be at most 0.04, which means that the margin of error at most is supposed to be 0.02. So look, got to go back, got to fix. I put margin of error is 0.04, but it's actually 0.02. To get the right answer, I apologize, but here we go. I got excited about statistics. So, final answer, 1686. Make sure you try these on your own and study, study, study.